Okay, this is part 2 of the matrix operations on TI-83. What you're seeing on the screen now is the point where we left off last time solving this particular set of equations. So let's go on and look at some more equations. So examples from the book. For section 4-2, here's example 3. So let's just go. We need to enter this matrix into our matrix on the calculator. So I do second matrix. I go over to the edit menu, hit enter, and it's already 2 by 3, so I don't need to change those, but I just need to put 2, enter, minus 1, enter, 4, enter, minus 6. And notice for the negative signs, I'm using this minus sign down here. 3, enter, and minus 12, enter. So double check. I got 4 and minus 12, minus 1 and 3, and 6 and minus 2. So I do second quit. And let me clear out the old stuff. You do second matrix, go over to the math menu, scroll to RF, and then you have to tell it which matrix to do that on. You do second matrix and use the names menu, tell it to RF on matrix A, and I get this matrix. This is a dependent matrix. It says x minus 0.5y is equal to 2. Okay, so and the bottom row just says 0 equals 0. Okay, so what it means is that these two rows, these two equations are basically the same equation, and you can tell that kind of by the fact that row 2 is just minus 3 times row 1 for each particular case. So any variable that satisfies, these equations, I guess we're using x1 and x2. So x1 minus 0.5x2 equals 2, or 2x1 minus 1 x2 equals 4. You can just pick a value, any value that you want for x1, and it'll tell you the value for x2. You can solve for that. So that's the relationship between the two. Let's look for example 4 on page 189. And again, I need to put this matrix in, so I do second matrix, go over to the edit menu. Again, I already have it listed as a 2 row by 3 column matrix, so I just need to put the numbers in. 2, 6, minus 3, 1, 3, 2. So again, double check, make sure I got it right. I do. Second quit. Now since RFA, and I just put this information in matrix A, RFA is what I want to do, which is what the last thing I do. I'm just going to do second entry, and it'll just recall my previous entry, which is what I want to do anyhow. So notice that we've got a different A here since we edited it, and this matrix is telling us that system of equations is inconsistent because the bottom row has 0, 0, 1, and the meaning of this bottom row mathematically would be that 0 equals 1, which is invalid. So this matrix, example 4, is inconsistent. Now if you did this by hand, you might end up with a different value than 1 in the lower right hand corner, but that doesn't matter. The calculator always converts it to a 0, 0, 1 in that bottom row. I mean, if you had 0, 0, minus 5 and you just divided the row by minus 5, you'd get 0, 0, 1 out of it, which is what the calculator does. And it doesn't matter. 0 doesn't equal to minus 5 any more than it equals to 1, so it's still inconsistent. We'll just look at a couple more cases here. Problem 39 on page 202. I need to enter that matrix, and it happens to be 3 rows by 4 columns. So again, I do second matrix, go over to the edit menu, and now I got to change it to 3 rows by 4 columns. So I just hit 3 enter, 4 enter, and it creates a matrix that size. So I just have to enter the numbers. 2, 4, minus 10, minus 2. And notice that it can only show 3 columns at a time, so it scrolls over 3, 9, minus 21, and 0, and 1, 5, minus 12, and 1. So let's make sure I got it right. Minus 201, 10, minus 21, and 12. Scroll back over to see my first two. I got 231 and 495. So I got that right. So I'll do second quit. But again, RFA is what I want to do. I could go back to the matrix math menu and pick RF, and then matrix names menu and pick matrix A, but it's just going to end up being the same thing, so I'm just going to do second entry. And so this is the reduced row echelon format for this matrix, and it's telling us that the solutions to these three equations is x equals minus 2, x1 equals minus 2, x2 equals 3, and x3 is equal to 1. And you can kind of double check that by plugging those values into, let's say, the first equation. 2 times minus 2, minus 2 plus 4 times 3 plus, minus 10 times 1 should be equal to minus 2, which is what it is. So I just plugged minus 2, 3, and 1 from this with x1 equal minus 2, x2 equals 3, and x3 equals 10, and calculated, and it came out to minus 2. And if you did that for each of the other two equations, you'd get the same answer. You know, this one would come out to 0, and this one would come out to 1. So let's look at one more problem, problem 47. So again, we have to put this matrix, we have to convert this into this matrix and enter it into the calculator. Again, go to the edit menu. It's the 3 by 4 again. So I just got to put 3 minus 4 minus 1, 1, 2 minus 3, 1, 1, and 1 minus 2, 3, and 2. Let's make sure I got it right. 1, 1, 2, minus 1, 1, 3, minus 4, minus 3, 2, and 3, 2, 1. So I got that right. And again, let me clear all this out. I'll do it instead of recalling previous entries. I'll do second matrix math, scroll to the RF, second matrix, pick name A, close parentheses, hit enter, and the reduced row echelon format for this matrix is this one. And notice, since our bottom row has all zeros except for 1 on the right, this matrix is inconsistent. There is no solution to this matrix, problem 47 on page 202. And that's what this row right here is telling us. It's telling us, again, 0 equals 1, which is not a valid mathematical statement. Let's look at multiplying and adding and subtracting matrices. And what I did was, on problem 31 in section 4-4 on page 214 of the text, I just picked 2 of those matrices. So let's put those 2 matrices, and we'll actually use the matrix A and matrix C on our calculator. So let's do second matrix and go over to the edit menu, and we want to do a 2-row by 3-column matrix in A. So I'll pick A to edit, and I need a 2 by 3, and the numbers in it are 2, minus 1, 3, 0, 4, minus 2, and 3 minus 2, minus 1, 4, 2, 0. So that's correct. So I quit out of that. I can quit. And I want to create a matrix C that's a 3 by 3. Second matrix, edit. Let's actually use matrix C. So I scrolled down to matrix C. So I'm going to edit matrix C. It doesn't have anything in it yet, so I need a 3 by 3 for that one. And the numbers are -1, 4, -2. Oops. Sorry, I was going down the columns. -1, 0, 2, 4, -3, 1, and -2, 3, and 5. So I got 2 and 5, 0, -3, 3, and -1, 4, -2. So I got that one in there. So I've got matrix A. I'm quit out of that. Let me clear this out. Matrix A is this thing. Matrix C is this thing. Find the product of A times C. A is a 2 by 3, and C is a 3 by 3. So there's as many columns in A as there are rows in C. The result of A times C, it's a 2 by 3 times a 3 by 3. The result is going to be a 2 by 3 because each element in the product is going to be this row. Let's say if I want to get this is going to, again, the product is going to be a 2 row by 3 column matrix. And row 1, column 1 of the result is going to be this row times that column. Row 1, column 2 of the result is going to be this row times this column. Row 1, column 3 of the result is going to be this row times this column. Okay? And all of the matrix multiplication works like that. Row 2, column 1 of the output is going to be row 2 of A times column 1 of C. Row 2, column 2 of the output is going to be row 2 of A times column 2 of C. How do we do that on a calculator? You can do math on matrices. You just have to pick the names from the matrix names menu. So do second matrix, pick A times second matrix, and scroll down and pick C. And there's our 2 row by 3 column. And let's just check and look at row 1, column 1 of the product is row 1 of A times column 1 of C. So 2 times -1 is -2. -1 times 4 is -4. So I got -2 and -4, that's -6 so far. And 3 times -2 is -6, so I got -6, so I got -12 as the product of these 3 numbers times those 3 numbers. And let's do row 1, column 2 is 2 times 0, so that's 0. -1 times -3 is 3. And 3 times 3 is 9. So 3 and 3 is 12. And so row 1, column 2 of the output is 12. And that's what the calculator did. Let's see if we reverse that and try to multiply C times A. I've got a 3 by 3 multiplying by a 2 by 3. It shouldn't be allowed. I don't have as many columns in A as I do rows in C. So if I reverse the 2 and try to do C times A, I'd be trying to take this row from C and multiply it by this column of A, and I don't have enough entries in A to do that multiplication. So let's see what the calculator tells us when we try to do that. Second matrix names, I go down to C times second matrix names A. And I get an error on a calculator. Dim mismatch means the dimensions don't match. Okay? So I can't do that operation. A calculator won't let you do it. Let's see if I'm going to take A and subtract 2 times A. I can't do add and subtract operations between A and C because you can only add and subtract matrices that have the same exact number of rows and columns. I'd either have to remove a row from C or add a row to A so that they would both be the same size. But I can take A minus 2A, and you could do that as long as if you had 2 matrices that were the same size, they were different matrices, you could add those together. So let's do second matrix A minus 2 times second matrix, and again I'm going to pick A, and we get a result. Okay, and it's basically just the minus of a, because a minus 2a is just minus a in any kind of math. So that's how you would enter a matrix equation for adding, subtracting. I mean, if you tried to do, let's say, a minus c, so say second matrix a minus second matrix c, again, you'd get a dim mismatch. The calculator won't let you do that because you can't add and subtract those two matrices. Let's find what c squared is. You can do that kind of an operation. Second matrix, we want to get the name c, and square it. You can multiply a matrix by itself as long as it has the same number of rows and columns. And so this row of c times this column of c is the first entry here. This row of c times this column of c is the second entry, row 1, column 2. And again, you do it row-column format. Row times column. Row 1, column 3 gives you row 1, column 3 of the resulting matrix. You can even do an inverse. You could take c to the minus 1, second matrix, go down to c, and do minus 1 on it. And it gives us a bunch of fractions that you got to scroll over to see. You can do math to fraction on a matrix, and it'll give you the matrix entries as fractions. So that's the c to the minus 1 power. That's called the inverse of a matrix. There are cases in more advanced math where that can be useful. So you can do all kinds of math operations on matrices. You just have to remember that when you want to tell the calculator to do something with a matrix, you have to pick it from the matrix names menu. You got to do second matrix, and to enter the name of a matrix that you want to do something to, you have to pick it off of this menu. You can't just, I'm going to quit out of this, you can't just type in bracket a bracket, because the calculator does not recognize that as a matrix. You have to use one of the built-in matrix names. And if you go to second matrix, they've got up to 10 matrices that you can use, and I've never had a case where that wasn't enough. So that's the rest of the demonstration on doing matrix math in TI-83.